Welcome back, everybody. Welcome back to the channel. So today we're going to be talking about how to parse while loops or while statements specifically. So we're going to jump right in. First, you're going to want to create your is function, and the token in question is while. So you're going to want to add that. And if we verified that the current token is equal to while, then we have our standard like blocking or our error message for saying illegal access declaration. And of course, we want to return true because we've successfully parsed a while statement. And once we go into here, while statements are very short. So, and you can even see here, you know what? I'm going to do while and while in the same video because they're literally almost the same and they're very short. So, we have our branch. So for while statements, you want to create your branch of AST while statement. You want to minus the current token because you guys remember when we're processing statements, we're going to actually be processing while. So we just want to expect while. I know that seems kind of silly. Like, why? Like if we know that we're in a while statement and we're processing it, why do we need to minus and then expect the exact same character that we just verified? The reason why you want to do this is it's a redundancy in your parser. You want to basically make sure that, or you want to ensure that what you're processing is exactly what you're expecting. You don't want to assume anything. So I know this is kind of silly, but that's kind of why I do it. And as you can see here, you don't need any of these freaking characters. So you can just say, add token is equal to false. And for while loops, it's very straightforward. All you do is you just expect the left paren, you expect a condition expression, you expect the right paren, and then you parse a block. Now let's look for do while statements as well. So for that, we can basically say AST while statement or AST do while statement. So we're going to create one of those, minus the current token, and expect do. And in fact, just to be comprehensive, I'm going to go up to do while statement before I continue talking about it. So to write under while, so we create your is function. So is do while statement, we expect do, and once we do that, of course, we block access declarations, and we basically call parse do while statement. Of course, after that, we return true. Let's go into here and see what we do. So like I said, we basically create our AST do while statement, AST or our branch, minus the current token, expect do, parse a block, call or expect while. You don't need any of these characters as well, by the way, so that's why I have false for all of these. So we expect while, we expect left paren, we expect what's called our condition expression, and we expect the right paren and a semicolon. So the way that do while statements work is, where is it? Okay, so the way do while statements work is you have some code and you want to say do and then while some, some expression is true. So the concept of do while versus while, here I'm actually gonna do this, while true. So the way that the differences between while and do while, and now I know some of you guys are like rolling your eyes, like I know this is like really simple. I'm just being comprehensive just in case someone doesn't know. So bear with me. But for while loops, the way it works is as long as this condition is true, we're gonna execute whatever's in here. And that's the same for this one, but the difference is when we get to a while loop, if this condition is not true initially, we completely skip over this block. Whereas a do while loop, we don't give a shit. What we're going to do is we're going to basically do the code first. That's what's called a do while. So we're going to execute the code first, and then if it turns out that whatever condition that we're checking turns out to still be true, then we're going to just go back up to the top and do the code again. So with do while loops versus while loops, you at least get one execution run of your code before you run the risk of not running that code again if your condition expression is set to false. So that's the difference between do while loops. Let's see kind of how they look. So I'm going to go take this code and go to while statements. Actually, you know what? I'm just going to do it here. Like I don't know why I'm doing all this. Okay, so we have our while statement and our do while statement, and we can kind of see what the compiler generates. Did it break? What's going on? This is weird. Oh, I guess not. Wow, so all of this code generated like 8 instructions. That's very tiny. Okay, so basically if we, oh, actually I need to go back here. So basically if we go back up to the top, You can see AST while statement. So this is how a while statement is generated. We have our condition expression. So we have two expressions here. So we have our condition expression of true, which seems to be correct and perfectly fine. And then our second expression is just a block. So it's whatever is inside of this block. And as you know, blocks are consisting of either more blocks or statements. So it's just going to be whatever that is. And then, of course, we have our do while statement, which is going to contain two more. So as you can see here, it starts off with the block. So first, we do the code inside of the block first, and then we process the expression after the fact. So if we look down here, we can kind of see how that code looks. This is why I thought it was broken, because this is just surprising how short this code was. So for the while loop, we say, we move one into the EBX register. We move EBX into the CMT register. The CMT is short for compute. It's basically just for branch. It's a register specifically for branches. And we can basically do this. So like we move one or true into the CMT register, and then we jump not equal to. So, I mean, obviously it's not going to jump over. It's just going to loop here forever. But if this value of the condition expression was not true, we're going to jump to 5. And 5 starts the code for the do while loop, which is even shorter than the while loop. But we can see here for while loop, before we end the while loop, we have this code here called jump at 0, which just jumps back up to the top to where we started processing our condition expression. So we check to see if this condition expression is true, and if it's not, we jump over it. Otherwise, if it's true, we execute whatever is in here, and then we basically jump back up to the top to do it all over again. After that, we move one into the EBX register, move it into the CMT. Now, again, this is inefficient. You're going to learn pretty soon that you really need optimizers when it comes to compilers, because compilers just generate extremely inefficient code. And I have an extremely efficient way in how I basically build my code. But for whatever reason, it's still not the greatest. And that's not 100% my fault. It's just you don't really have all of the context of what's actually going on when you're compiling things. So you just have to make loose assumptions, and that creates inefficiencies. But anyway, we basically move our EBX to the CMT register, so that way jump not equal to instruction can process it. And we jump if equal to at 5. So 5 is basically this code here. So basically just looping here forever as well. But as you can see, I mean, even though I don't have any code here, like you can kind of see like, or you could expect that this code is going to run first, and then we then evaluate whether or not it's true, and then we jump up to the top again if it's true. It's like here, I'm going to actually do this. So I'm going to say I is equal to 0, and we can kind of see how do while loops are generated. So we have the same crappy code that we have here. So we have, move one, whatever. But here's a different thing. So we move 0 into EBX, and then we move that into frame pointer of 1. So that's going to be, this variable here, this local variable. And we call move I of 1, move that into the CMT register, and jump not equal to. So we jump at 5, which starts the code where we start processing this. So yeah, this kind of proves and shows that we execute the code before we even check to see if the value of whatever we need to check is true. So that's going to be it for today, guys. As usual, if you guys have any questions, definitely write it in the comment section below. And of course, if you guys would love to help support the channel, definitely head over to my GitHub repository at androdevcd/sharp. When you get there, definitely watch, star, and fork this repository. That's going to give this language a lot more visibility and let other developers know this language exists. Also, if you're curious about maybe seeing some of the things that I do on a daily basis, check out the remastered branch. And once you guys get there, you can check out the commits. I write some pretty wordy commits, so you can kind of get a gist of what I've been up to without really having to look deep into the code. And of course, if you guys are curious about maybe some of the things that I'm looking to add into the future for the YouTube series or for the language in general, or maybe even stuff that I did in the past, you can check out the doc folder. And that's in there, you're gonna have two main files. So you're gonna have the changeless file, which is not really updated, as you can see. And that's gonna be all the old stuff that I've done to the language already, that's already in the platform. Then of course you have the roadmap file, which not only contains old stuff that I've done, but also all of the new things that I'm looking to add into the future. So that's going to be it for today, guys. As usual, if you guys are new to the channel, definitely consider subscribing. And until next time, I'll see you guys later.